welcome to Chem 2005. Today we will talk about fused six-member rings. We will talk about quinolines and isoquinolines. Okay? First of all, we will analyze both compounds are aromatic. Okay, and because they have a pyridine ring, all will be electron poor. That means if they are electron poor, means that will go very well in the nucleophilic aromatic substitution and will not work, or will work very few with the electrophilic aromatic substitution. As usual, when we have two rings, whatever are the two rings, fused, we have to check which are the characteristics of each ring. That means this ring, that is a pyridine ring, will be more electron poor, and this will be slightly more electron rich. Okay? That means if we are doing a electrophilic aromatic substitution, okay, for example, we are treating this nitric acid in sulfuric acid. Okay, what will happen is that the nitration will go to this ring. We will put an example. We add activating group in order to make it easier. Okay, the nitration will go to the ortho position of the aromatic ring that doesn't contain the nitrogen. Okay? Which position will go? Basically, will go to the 1,4 positions. Okay? In this case, we'll go to this position because it's ortho to the activating group, that is the methoxide. Okay? This is basically the reactivity. The electrophilic aromatic substitution, the two favored positions are the two that are close to the pyridine rings. Here and here. But it's not working well. The thing that will not happen is that the electrophilic aromatic substitution goes to this ring. Okay? This will not happen. If we want an electrophilic substitution in this ring, what we need to do is an analogous reaction that we did with the pyridines. Okay? Basically, what we need to do is we have the isoquinoline, okay, and the first step we use MCPBA to oxidize the pyridine and once we have the pyridine N oxide, what is happening is that if we do electrophilic aromatic substitution, as example, this, the nitration, we will have the nitration in the same way than the pyridine. This now is an activating group, is an activating thing, is an activating ring. That means that will favor ortho-para. Para is always normally easier to attach, to approach. That means that will be the nitration in the para position. Okay, this is totally analogous of what we did with the pyridines. Okay? Good. Then in the nucleophilic aromatic substitution will work very well. Typical examples are, remember that this is a pyridine ring, that means if we have a leaving group in this position or in this position, remember X. What will happen is that we have the substitution very easily because it's electron poor ring. Depending on where we have the leaving group, we will have the ortho or para. Okay? But remember, the only active positions are ortho or para regarding the nitrogen of the pyridine. Exactly the same chemistry that we saw in the case of the pyridines. How we can synthesize these compounds? Well, the synthesis of these compounds in the case of quinolines, okay, what we can do is we start from an aniline and basically what we have is we need to add an alpha unsaturated ketone, or could be an aldehyde. What is happening is first we have a Michael addition. Okay, we have the Michael addition followed by an intramolecular Friel-Crafts reaction. Basically, this ring is electron rich because we have an amine and will attack, following electrophilic aromatic substitution, to the ketone. That means that what we will have this intermediate, we do the rearomatization, we get the aromatic compound, and then the aeration to form this compound, followed by oxidation that can be done by air or by can, are the two typical methods to form finally the quinoline. Okay, this is the synthesis of quinolines. Basically, we start with an aniline and then we will react with an alpha beta unsaturated ketone or an alpha beta unsaturated aldehyde. Okay, first Michael addition followed by intramolecular 1,2 addition. In the case of isoquinolines, we have to start with a slightly more complicated substrate. We have this compound. We have to start with this substrate. Okay? First step, we do an amide. How we can do it? There are a lot of methods. Please follow what Bruno explained to form amides. But basically, we can use an acid chloride with pyridine. We can use an acid and a coupling reagent with like EDC or EDI. If we do this, what we get is this compound. Okay? And then what we are doing is treating this with PCl frame. Okay? What we do is we generate this acetylene, okay? And simply when we are here, intramolecular addition, and what we have okay, we regenerate the aromaticity of the compound. And then what we get is we regenerate the double bond and the leaving group is departing to form this compound that again can be oxidized by air or can to generate the final isoquinoline. Okay? We saw these mechanisms in the notes. Please check it. Okay? And this is how we can form isoquinolines. That's all what I want to explain about the synthesis of quinolines and isoquinolines. It's very fast. See you soon in the next lecture that will be probably diazines.